So class, now we are going to determinant of 3 by 3 by using second method, which is minor and cofactor. If given to us this matrix A with all these elements, we need to find the determinant by using this minor and cofactor method. It can be obtained by using this formula. That is, this matrix A determinant can be computed by Aij, the sum of Aij times Cij. What does it mean by Cij here? It is the cofactor matrix. And then this Cij can be obtained by using this formula. That is -1 power I plus j times Mij. What does it mean by this M? So this M is minor. That's why we call this method as minor and cofactor. So here class, there are two important things that you need to know. The cofactor here is defined as Cij, which is given by this part. So we have here this formula. And then the minor Mij. Before we compute this Cij, we need to know our minor. How to compute the minor? It is the determinant. Determinant of the matrix. That is, we obtain by eliminating the I row and j column. I will show you in detail for the next example. So we go to this example 3. We have here a matrix A with this element. We have two questions here, which is first we need to evaluate the minor and cofactors of the matrix associated with the first row. This one is important because from here you know you will eliminate the first row and column 1, then the first row, column 2, the first row, column 3. And then for B, we need to find determinant of the matrix. Let's do first for A. We need to evaluate first the minor. How to compute the minor? Okay, we have previous knowledge, which is the theory of the minor is a determinant of the matrix by eliminating I row and j column. When we have here associated with the first row, so you need to eliminate the first row. When you eliminate the first row, you need to eliminate again j column 1 by 1. So we have here 3 columns. When we want to compute here M11, means that you see here you have row number 1 and column number 1. In this case means that we need to eliminate the first row and the first column. So for this case, we have to eliminate this first row and then this column. When we eliminate this one, the definition for minor is given by determinant. So you have determinant of the matrix. That is, the first row and the first column is eliminated. So the element here only have this 2 by 2 matrix, which is here we have 5, 1, 4, 5. So we compute determinant of this 2 by 2 matrix because we already eliminate the first row and the first column. Means that class we have 5 times 5 minus 4 times 1. So we got the answer 21 for the first minor. You cannot just leave your answer like this because your minor, when you associate it with the first row, and then you need to find the minor for all column. Means that here you have first row, second column, first row, and also third column until all column is completed. So for the second one, we have minor when the first row and the second column is eliminated. That is the first row and then this column. So that we will have here this element and this element. Means that it is determinant of -1, 3 and 1, 5. In this case, we got the determinant of -1 times 5 minus 1 times 3, which is equal to -8. And then for the last one, means that the first row is eliminated and also the third column is eliminated. So in this case, we'll have this first element and this one as your second column of elements. So you have here -1, 3 and 5, 4. So we have negative 1 times 4, and then minus 5 times 3, which is our answer for this one is negative 19. And then for each minor, we need to compute cofactor. Minor M11 will give us C11. We know that the cofactor is given by, for Cij, it is negative 1 power I plus j times Mij. So here our I is 1 and j is 1. We have here negative 1 times 1 plus 1 because this is I, this is j, M11. The answer here negative 1 power 2 and M11 is given by this 21. So times 21 we'll got the answer here 21. And then for the second cofactor, which is C12, negative 1 power 1 plus 2 M12, which is negative 1 power 3 times negative 8. This one you will got negative, you times negative 8. So the answer is 8. And then for C13, negative 1 power 1 plus 3 M13. So equal to negative 1 power 4, negative 19, means that for this one you will got positive times negative 19, we will got negative 19 as the answer. And then number B, we need to find determinant of the matrix. So this is the solution for A. For B, we have to refer back. The determinant is given by the sum of Aij times our cofactor. Means that here, this determinant of the matrix A equal to the sum of Aij times our cofactor Cij. In this case, we have C11, C12, C13. So you should make it consistent with the I and j in cofactor for this element for Aij, which is here we have A11 times C11 plus A12 times C12 plus A13 times C13. A11 based on the matrix is given by 2. So we have here 2 times 21 plus, and then A12 is given by again these 2 times 8, and then plus 0 times negative 19. When we solve this one, we'll got the answer equal to 58. So this is the determinant for this matrix. And then class, we go to this example 4. This example 4 asks us to find the determinant of the matrices using minor and cofactor. We have here 3 matrices. So I will solve for this one only for A. For A, let's say I use first row and then first column, second column, third column. So for determinant of A, I can compute it using A11, C11 plus A12 times C12 plus A13 times C13. In this case, I need to find first M11. M11 equal to determinant of 5, 6, 8, 9, which is 5 times 9 minus 6 times 8. We'll got the answer negative 3. And then for M12 equal to determinant of the first row, and the first row is closed and then the second column is closed. So we have only element 4, 6, 7, 9. When we solve this one, we got the answer negative 6. And then for M13, we have here determinant for 4, 5, 7, 8. This one, the answer is negative 3. And then we compute here cofactor C11 equal to negative 1 power 2 times negative 3, which is here the answer negative 3. For this C12 equal to negative 1 power 3. Why 3 here? Because 1 plus 2 and then times negative 6. So the answer here will be equal to 6. And then the last one, C13 equal to negative 1 power 4 times negative 3. So we got the answer equal to negative 3. When we want to compute determinant of A by using this formula, we have here A11 equal to negative 1 times negative 3 plus A12 is 2 times 6 plus A13 is 3 times C13 is negative 3. The final answer here is equal to 6. And then for B and C, I will leave it as your exercises. Thank you for your attention. We will see later in the next video, which is how to find inverse of the matrix.